Okay, we are going to go over the warm-up now. And the first one is carbon tetrachloride. Remember that these are covalent compounds, non-metal, non-metal. The first step to a Lewis structure, also known as an electron dot diagram, interchangeable, is to determine the total number of valence electrons. For carbon tetrachloride, you would have one carbon with 4 valence electrons. Remember where you get those valence electrons from? It's not total electrons. It is valence electrons, only the electrons in the outermost energy level. And that you would get from the periodic table, of course, and read up to the group number. And then you have 4 chlorines. Each chlorine has 7. So 4 plus 4 times 7 equals 32 electrons. Please make sure that you write that number down. Don't think you'll remember it. So then you need to determine the central atom. It's generally the one that's first. If it's carbon, it will be the central atom. Carbon loves to be a central atom. Arrange the peripheral atoms, or the outer atoms, around it in a kind of symmetric way, so 4 chlorines around. Then you need to connect with single bonds. Remember that every time we draw a dashed line, that is representing 2 electrons. That is representing a filled orbital, 2 electrons that are shared. Both atoms, the atoms on either end of the dashed line, are feeling the effects of those 2 electrons. The next step is to give the outer atoms an octet. Ignore the central atom for now. And you do that until you run out of electrons. In our case, we have a lot of electrons, so we're good. We can just put sets of 2. Notice that these are lone pairs that we're putting around there. If we look at one of the chlorines, we would see that there are 6 dots and then 1 dash. The 6 dots, there's 2 dots on the left, 2 dots on the top, 2 dots on the right. Those are 3 pairs of electrons, 3 lone pairs on that chlorine, and then 1 bonding pair, 1 pair of electrons that are part of the chemical bond. Pairs only. Everything you have will be a multiple of 2. It's either going to be a bonding pair, that's 2, or a lone pair, 2. No single dots ever. It's either a dash, which represents 2, or you'd have 2 dots together. That is a pair. Then the next step, so count up your electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. 32 electrons have been used up in drawing that structure. The outer atoms all have an octet. Now you check your central atom. Check the central atom. It feels the effects of 2, 4, 6, 8 electrons. It has 4 bonds around it. Every bond is 2 electrons. That's 8 electrons. Every atom has to have an octet, has to feel the effects of 8 electrons, with one exception, and that's hydrogen, which we get to in a moment. Next one is CS2. 4 valence for carbon, 6 for sulfur, and there are 2 of them. We get a total of 16. Write that number down. Central atom, arrange the outer atoms as an octet around it symmetrically. Connect with single bonds. Give the outer atoms an octet. In the process of doing that, we use 2, 4, 6, 8, 10, 12, 14, 16 electrons to give the outer atoms an octet. Can't stop there. Check the central atom. The central atom feels the effects of 2, 4 electrons. That is not 8. That is not an octet. You cannot stop here. This is not a correct electron dot diagram. So what do? We cannot give carbon lone pairs because we don't have any more electrons. So we have to move some electrons. We kind of pick up those 2 electrons on the left and put them over there and make them double bond. Is this really how double bonds are formed? Definitely not, but it is a method that gives us the correct electron dot diagram. So we moved those 2 electrons in the lone pair to become part of a double bond. Same thing on the other side. This is the structure that you'll end up with. You would end up with the carbon feeling the effects of 8 electrons, 2, 4, 6, 8. 4 dashes would represent 8 electrons. The sulfur also feels 2, 4, 6, 8 electrons. Same thing for the other sulfur. That is the correct electron dot diagram. pH3. We have 5 for phosphorus, 3 hydrogens with 1 each. We get a total of 8. Notice how you're getting these multiples of 8. It's not always a multiple of 8, but very often you get some multiple of 8. 8, 16, 24, 32. Phosphorus in the middle, arrange the hydrogens around in a nice little organized way. Connect with single bonds. When we do that, we have used 2, 4, 6 electrons. We have 8. Where did the other 2 go? Cannot give them to hydrogens. Hydrogen wants to feel like helium. Hydrogen, if it feels the effects of 2 electrons, it thinks it's helium, a nice stable electron arrangement of a noble gas. So, hydrogen, you're going to want to write this in your notes, hydrogen, 1 single bond, that's it. 1 single bond. Never, I do not use never lightly, never lone pairs for hydrogen. Never double bonds for hydrogen. What's the rule for hydrogen? 1 single bond, that's it. Once you have connected it to the other atom, you're finished. You cannot do anything else to hydrogen because it feels the effects of 2 electrons, it thinks it's helium, it's good. Where now you check, so those hydrogens are happy. They feel the effects of 2 electrons each, they're good. Where do the other 2 electrons go? Phosphorus. Check phosphorus, 2, 4, 6, 8. I've used my exact number of valence electrons that I started with, no more, no less. Last one is H2O. You must be able to do the electron dot diagram for water. You cannot leave chemistry without being able to do that, knowing some things about water. So we've got 2 hydrogens, 1 each, plus 1 oxygen. That gives us a total of 8. Central atom's going to be oxygen. Oh, one other thing you could put in your notes for hydrogen, never a central atom. Can't be, because 1 single bond, that's it. It could never be a central atom because then it would have to have a bond on either side. So hydrogen, never a lone pair, never a double or triple bond, never a central atom. As usual, hydrogen is a little unique. Okay, so we've connected with single bonds. That uses up to 4 electrons. We have 4 more. Not going to give them to hydrogen because no lone pairs on hydrogen ever. Now we're going to give those other 4 electrons to oxygen. We have used 2, 4, 6, 8 electrons. That's how many we needed to use. Oxygen feels an octet. Each hydrogen feels the effects of 2 electrons. You have the correct electron dot diagram.